This single battery cell could simply reshape how electric cars are built, what they cost, and whether millions of Americans who've been on the fence about EVs finally decide to make the switch. Tesla's 4680 battery doesn't look like much from the outside, just a metal cylinder about the size of a D-cell flashlight battery, only wider. The name itself tells you the dimensions, 46 millimeters across and 80 millimeters tall. Nothing fancy about that label, but what's packed inside represents a genuine shift in how electric vehicle batteries are designed, manufactured, and priced. To understand why this matters, you need to know what came before it. Tesla and most other EV makers relied on smaller cells called 2170s, which measured 21 millimeters in diameter and 70 millimeters in height. A single Tesla battery pack required thousands of these smaller cells, all wired together in a dense and complicated network. Every connection between cells introduced a small amount of energy loss and added complexity to the manufacturing process. More connections also meant more potential failure points and more heat building up inside the pack. The 4680 cell is roughly double the size of those older units, which means each one stores significantly more energy. Fewer cells are needed to do the same job, and that single change cascades through the entire vehicle. Wiring becomes simpler. The number of internal connections drops dramatically, and the whole battery pack ends up lighter and more streamlined. Think of it this way. If you once needed 1,000 small pieces to build something, you can now accomplish the same result with 600 or 700 larger pieces. Fewer parts means faster assembly, lower cost, and fewer things that can go wrong down the road. But the real engineering breakthrough sits inside the cell itself, in what Tesla calls a tabless design. In older battery cells, electrical current entered and exited through small metal tabs, tiny connectors that funneled all the energy through a single point. That concentrated flow created hot spots where heat would build up, which degraded performance over time and raised safety concerns. Tesla's engineers essentially eliminated those bottlenecks by redesigning the internal structure so that current flows evenly across the entire cell rather than squeezing through one narrow pathway. Picture a 4-lane highway replacing a single-lane road, and you get the idea. Traffic moves smoothly in every direction, nothing overheats, and the whole system operates more efficiently. That even distribution of current solves one of the oldest problems in EV battery design, which is heat management. Excessive heat reduces how far a car can travel on a single charge, shortens battery life, and in extreme cases creates safety risks. Because the 4680 spreads its electrical load across a wider surface area, heat doesn't concentrate in one spot. The larger cell size also gives the cooling system more surface to work with, which keeps temperatures stable during hard acceleration, highway driving, and fast charging sessions at Tesla's supercharger stations. For the person behind the wheel, all of this translates into 3 practical benefits. The first is range. A battery that stores more energy and loses less of it to heat and resistance can push a vehicle farther on a single charge, which matters enormously on long trips and in areas where charging stations are still sparse. The second benefit is acceleration. Tesla vehicles already deliver instant torque, and the 4680's smoother power delivery makes that response even more immediate when you press the pedal. The third benefit involves charging. Lower internal resistance means the battery can accept energy more quickly and safely, so time spent at a charging station becomes a bit shorter, and the process puts less stress on the cells. None of those improvements matter much, though, if the battery costs too much to produce. And this is where Tesla's ambitions get truly interesting. The battery accounts for somewhere between 30 and 40% of an electric vehicle's total price. Materials like lithium, nickel, and cobalt are expensive, and processing them adds even more cost. That's the primary reason EVs still carry higher sticker prices than comparable gasoline-powered cars. Tesla's goal with the 4680 is to attack that cost problem from the manufacturing side. Fewer cells per vehicle, simpler assembly, and highly automated gigafactory production lines all work together to bring the per-unit cost down.
Tesla has stated that this technology could significantly reduce battery costs over the long term, and when the battery gets cheaper, the vehicle gets cheaper. That cost reduction connects directly to something Elon Musk has talked about repeatedly: building an affordable Tesla for the mass market, a vehicle priced low enough that middle-class families can seriously consider going electric without stretching their budget. If that happens, the ripple effect could accelerate EV adoption the same way falling prices turned smartphones from luxury gadgets into something nearly everyone carries. Tesla isn't pursuing this goal in a vacuum, though. Competition in the EV space has intensified considerably. BYD, the Chinese automaker, has emerged as Tesla's most formidable rival. BYD manufactures its own Blade battery, which takes a different approach by prioritizing safety and durability over raw performance. The Blade battery carries a lower risk of overheating and has proven especially practical in commercial applications, like taxi fleets. BYD also controls its own battery supply chain and benefits from lower manufacturing costs in China, which allows the company to price its vehicles aggressively. In China's massive market, BYD already outsells Tesla. The dynamic between the two companies boils down to Tesla chasing performance and innovation, while BYD competes on value and reliability. Toyota presents a different kind of challenge altogether. Where Tesla has committed entirely to a fully electric future, Toyota continues to invest heavily in hybrid technology. Toyota's position is that the world can't switch to pure EVs overnight, particularly in countries where charging infrastructure remains underdeveloped. A hybrid vehicle, running on both a gasoline engine and an electric motor, offers fuel efficiency without the range anxiety that still worries many potential EV buyers. Tesla counters that hybrids are a half measure and that the future belongs to zero-emission vehicles integrated with advanced software and connected to a growing network of superchargers. Which philosophy wins out over the next decade remains genuinely uncertain.
Traditional automakers like Volkswagen and Hyundai have also entered the race with serious investments in electric vehicle development, which means the competitive pressure on pricing and technology will only increase. The likely outcome is a pricing war that benefits consumers through lower sticker prices, more choices, and faster technological improvement, even as it squeezes profit margins for every manufacturer involved. Beyond batteries and cars, Musk's longer-term vision extends into territory that sounds ambitious even by his standards. Tesla's full self-driving technology is being developed with the goal of eventually enabling a robo-taxi service, where your parked car could generate income by picking up and dropping off passengers without anyone behind the wheel. Tesla also envisions a complete energy ecosystem connecting electric vehicles with solar panels and home battery storage so that your house and your car both run on clean energy from the same integrated system. The gigafactories themselves are part of that vision, designed to become progressively more automated with each new facility, following Musk's stated philosophy of building the machine that builds the machine. Whether all of this comes together as planned is the question that hangs over everything Tesla does. The 4680 battery is real, it's in production, and the engineering advantages are measurable. Bringing down EV prices to a level that works for everyday American families, though, requires executing on manufacturing at a scale and cost that no company has fully achieved yet. What's clear is that the direction of the auto industry has already shifted. The battery sitting at the center of that shift is a cylinder you could hold in one hand, and the changes it represents are ones that every car buyer in America will eventually feel, whether they choose a Tesla or not.